Good day, everyone. Welcome back to day two of JavaScript workshop series. First of all, amazing job yesterday. You wrote real code, interacted with the DOM, and built your first interactive mini application. That's a huge milestone. Today, we take an important step forward. Every great developer starts with a single line of code, and that line moves one step closer to professional level engineering. You have already seen how JavaScript brings website to life. But now imagine something even more powerful, a programming language that protects you from mistakes even before they happen. That language is TypeScript. So let's start with TypeScript. Think of TypeScript as JavaScript's smarter, more organized sibling, the one who labels everything neatly, measures twice before cutting once, and makes sure no tool is misplaced. Let's say in JavaScript, you could put anything inside a variable, a number, text, object, even by accident. TypeScript stops you and asks, hey, what exactly are you planning to store inside that box? Label it properly so you never lose track. And suddenly, programming becomes safer, cleaner, and easier to debug. Picture yourself walking into our innovation lab, but this time everything is reorganized. Shelves are labeled, machines are sorted, clear safety warnings. Welcome to the TypeScript lab. So let's start exploring TypeScript. So let's create our first file. Let's create this as JavaScript. So in JavaScript, let's say I have a variable as a and I define it to be a string. Hello world. Now in JavaScript, I can also reassign this variable. So this is allowed in JavaScript. But then this coding practice is not a good practice since it creates issues in larger applications. So what TypeScript does is TypeScript forces you to actually assign what this variable will store. So whether it's a string or a number. So let's create another file. Yeah. And in this, let's have the same variable, but this time we label it that it will store a string saying hello world. Yeah. Now to run this code, yeah, I will just also console the variable. Uh, to run this code, we open the terminal. Yeah. First, we have to do TypeScript compile. So to compile it in TypeScript, the command is tsc, the file name. So that is tsc dot ts. What this command will do is it will compile your TypeScript code into JavaScript. So it will create a .js file. So I'll just run this command. Yeah, and as you can see, it has created a temp.js or JavaScript file. And now we can run this JavaScript file. So I'll just use the command node temp.js. And yes, it has printed hello world. Now let me try to redeclare this variable a as a number. So I will just do this, a is equal to 10. Yes. And let's do TSC again. Yes. So as expected, TypeScript has thrown an error saying type number is not assignable to type string. So I can't reassign my variable a. So that is the power of TypeScript. Once you define that a particular variable will be of a particular type. So in this case, my variable a is of type string. I cannot redeclare it as type number. So this actually protects from further issues so that my variables are easily labeled actually. Now let's go into more in depth. So TypeScript has a few types actually. So that is number, string, boolean, and any. So string we have seen. Any variable that I want to store a string into, I will use the string label. Let's say I want to store numbers. So I will define it like this, number equal to, let's say 10. Yeah. And now I can just console log this also. I will compile this. Yes, and let me just do this. Yes. So this is number. Then there is boolean. Boolean is, let's say we want to store some boolean values, so either true or false. So that we can do using the boolean keyword. So let me just store boolean equal to true. Let me just store this. Let me console this as well. I will do a TSC. Yeah, and let me do node. And yes, this is a boolean value. Then any is used to store anything in a variable, which is like you kind of override the TypeScript's default behavior over here. So in that case, what I can do is I define it as any. So it can store anything. It can store a string, it can store a number, it can store boolean, it can store anything. And let me store an object this time. So name is equal to, I'll use this. Yeah, let me do the TSC again. Oh, I missed the console. Mm, yeah. And yes, it has output the object also. Now let's say this thing, I have some function, but that particular function doesn't return any value. Let's say it is just a simple function that console logs the value of D. So it doesn't actually return any value. So in that case, those functions we can define using the void keyword. So let me just show you a demo function. Let's say function greet. It doesn't take any arguments, but it doesn't return anything. So we'll define it as void, and it will just uh, console log this. So log this. Yeah. Let me just comment this as well. Yeah. Let's do the TSC. Let's run this code. Uh, oh, I have to call this function. Missed that. And yes. So this particular function, as you can see, it doesn't return any value, but it just console logs the value of D, the object over here. So in that case, I've defined this function using the void keyword. Now let's say there is another function which runs endlessly. So it doesn't end actually, it runs infinitely. So in that case, we can set the keyword as never. So let's say I have some function named as add. Let's say uh, I'll use some default this thing values. I just do this while true and this, yeah, just this. Now let me call this. Let me console log the this. Let me comment this. Okay, and in place of greet, I will call this add. Yeah. So now this my add function runs endlessly because this while true is always true. So this function will run endlessly. So in that case, I've defined this using the never keyword. So let me just do the types compile. Yeah. And let's run this code. And yeah, as you can see, it doesn't stop actually. It will run endlessly. So yeah, uh, yeah. My next is arrays. So arrays are basically organized shelves. So let's say I have an array that is that stores some tools. So let's say it stores like let's say hammer, then let's say some screwdrivers, wrench. Yeah. So this is my array having it is a array of string. But as you know, your TypeScript will throw an error. Oh, I've used the variable a. Let me just redefine it to say tools. Yeah. Now, if I compile this code, TypeScript will throw an error saying tools is doesn't have a type defined. So let me just define the type over here, saying that it's an string and an array. It's an array of string. Yeah. Now let me just console log this. Console.log tools. Yes. Let's do the TypeScript compile. Yes. And let's run this code. Yes. Perfect. It has outputted the tools, this thing. Now there is another uh, keyword known as tuples. So tuples are basically special arrays wherein we know what a particular index, what kind of data will be stored. So let's say I have some this thing, like I have the machine status. Like this is my tools. I have another array storing the machine status, and that, let's say at the first index, I want it to be a string. The second index, it will be a number, let's say. The third will be a boolean. So whether it is true or false. So in this case, let's say now, since I've defined the first index to be a string, let me just store some number over there. Krishna. And then let me just store as true. Yeah. As you can see, this will throw an error because at the second index, it wants a number. But here it is getting operational, which is a string. So this TypeScript will throw an error over here. So what we can do is we can just store it like this. So yeah, let me do the TypeScript compile, and yeah, let me just also console log this. Yes, yes, see. Yes, perfect, no errors and node. And yes, this is my tuples. It's basically a special case of array where we define what value will be stored at that particular index. So now we have enums. So enums, you can think of it like objects in JavaScript. So to define enums, we define it as enum. Let's say I want to store the machine state, machine status. Yeah. And let's say it is off, or it is idle, or it is running, or maintenance. Yeah. Let's use this uh, machine machine state. Yeah, machine state. And now let's say the current state is, yeah. Let's use this. I will just console log this. Console.log the current state. Yeah. Let me just do the TypeScript compile. Yes, perfect. No issues. And yeah. So over here, the current state is running. So that is the array index 2 over here. Now let me just do a sample code kind of. So let's say I will add a code over here. Let me just create another file that is temp. Yeah. Yeah. So in this code, what I'm doing is I'm setting one Boolean value is door locked. I'm setting it to false over here. Then I've defined my tools as an array of string. It store all my tools, that is hammer, pliers, drill. I've defined an enum for mode, that is off, running, maintenance. And I've set the active mode to be running, mode.running. Then I have my function announce, which is void since it doesn't return any value. It just console logs the message, whatever message I pass into. I'm calling the announce function and I'm passing this message. Current mode is the active mode. And I'm doing a console log tools over here. So tools is this array over here, array of string. So yeah, let me just do the TypeScript compile for this, which is temp2. Yes, perfect. No errors. And let me just run this code. And yes, so current mode is 1. That is, it is running. And these are my tools. That is hammers, pliers, and drill.
So Nandan, I would like to ask some questions as a viewer perspective, as a student. So,
Sure, sure.
can you explain us this thing like first you run the code in the command line, that tsc temp.ts, and then node. Can you tell why
Yes.
are we doing this? Like, if we are writing the code in TypeScript, then why do we need a JS file?
Yeah, sure. I can explain that. So we need a JS file since Node can't run the TS files directly. They can't run the TypeScript files directly. So what this command does, tsc temp.ts, is it compiles your temp.ts code into JavaScript. So basically what it does is it converts your this TypeScript code into plain JavaScript. And then this command, the node temp.js, this command runs your JavaScript code. So as you can see, like this is my temp2.ts. I will delete this temp.js. Mm, Let me just delete it. Yeah. And now once I do the tsc for temp2.js, ts, it will create a JS file over here. So what that JS file is, it is simply this TypeScript code converted into JavaScript. So yeah, let me just run this code. Yeah. And as you can see, it has created a JS file. And as you can see, it is same. Your code is same. It's just that it has converted into JavaScript. So as you can see, it is not here. If you can see over here, let me just split it over here. Yeah. So as you can see, in my TypeScript code, this is door locked is Boolean. But in my JavaScript code, that Boolean uh, this thing, the identification is not there, identifier is not there. Even for these tools, the string array is not there. So it converts my
Hmm.
TypeScript code into plain JavaScript code, which then I can run the node command to run this particular code.
Then, can you please tell us what exactly is the difference between TypeScript and JavaScript? Like, in the end, we are converting the TypeScript into JavaScript. Then, why aren't we only using JavaScript when everything needs to be in it?
See, using plain JavaScript creates an issue. In TypeScript, what we can do is we can label every variable to be of a particular type. So let's say this variable, for example, is door locked. Since I've labeled it as Boolean, I know that this particular variable will store only Boolean value. In JavaScript, I can store anything inside this. So is door locked? I can store false initially. But then later in my code, I can also do this thing. I can also store some number in it. I can also store some string in it. So that way it becomes confusing actually. So once your code expands, it becomes big. That time to track what every variable stores becomes an issue. But what TypeScript does is TypeScript throws an error saying that this particular variable cannot be like this particular variable is a boolean, and if I try to store string in it, it will throw an error saying string can't be stored in type boolean. I will also show you the demo for that. So let's say is door locked is over here, and now what I do is I try to store a string in it. Mm, is door locked? Let's say I'm storing some string in it. Yeah, and let me do the TypeScript compile for this. See, this is the error that TypeScript throws. Type string is not assignable to type boolean. So this is the reason we code in TypeScript so that it becomes easier for us to track what every variable will store in the code.
Can you show the same in JavaScript as well to the viewers so that it's a bit more clear?
I'll show it in JavaScript as well. So let me just create another file or else wait, I'll reuse this file. Yeah. Mm, yeah. So let's say I have a variable saying as a, which is true, which stores boolean value. I will console this as well here. I will say this is the initial value of A. Yeah. Now let me store a string in this. So that is hello world. Yeah, after reassignment A. Now let me just run this code. That is node index.js. Yeah, like you can see, this didn't throw an error. So my initial value of A was true, and then I've reassigned it to a string, and I've console logged after reassignment the value of A. So that is hello world. So this actually doesn't throw an error, but this is not a good practice, since I want to know what if I've assigned this particular variable, that is A, to be true, so a Boolean value. So I want to store only Boolean values in this. I don't want it to change the type of data that it stores. So that is the reason TypeScript is preferred.
Okay, so you're saying that even when in JavaScript you have assigned the same variable to different things, it will run. But in TypeScript, if we do that, it will throw an error.
Correct. Correct.
Right. Okay. So can you go back to the previous file?
Yeah.
Yeah. Uh, I wanted to ask that while you were coding, code was automatically getting typed here. Are you using some
Yes.
kind
Yes.
of extension in VS Code, which everyone should use now?
Yes. Yes. We can actually enable that prompts over here. So um, that is this thing, the VS Code extension for prompts. So
Okay.
that autocomplete kind of.
Nandan, you also explained about the any type. Can you
Yeah.
explain more about it? Like, how is it useful for us as a coder?
Sure. 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 So any type, basically you can imagine it as a box which is not labeled kind of. So let's say in that particular box, I'm storing my tools, I'm storing let's say my lab coats, I'm storing anything which I have, kind of like a miscellaneous box. So it can store anything. It can store tools, it can store lab coats, it can store, let's say, some lab equipments also. So it can store anything. So it is not like this thing. It is not what I can say. It won't throw an error saying this particular variable should be of type boolean or should be of type string. Since any, it can store anything.
So, like, in JavaScript, the file just you made, you didn't
Hmm.
specified anything, right? So, like, you're saying in TypeScript, we use any and we can store anything there. But in
Correct.
JavaScript, you have not written the keyword any, right?
Yeah.
But you are still storing it. So, can
Yes.
you
Correct.
explain this a bit?
So in JavaScript, by default, I don't have to use the any keyword. The any keyword is specific to TypeScript. Since TypeScript wants, like, let's say I define a variable, then TypeScript wants me to define what that variable will store. So whether it's a string, whether it's a number, or whether I can store anything in it. So even an object, even an array, even a string, anything, then define it as any. But in JavaScript, by default, you can store anything inside a variable. So that's the reason I don't have to define uh, explicitly that the any keyword with the any keyword over here. So yeah, today you have upgraded from JavaScript workshop to the TypeScript lab, a place every variable is labeled, structure is enforced, and mistakes are caught before they break the system. This is where TypeScript is the standard for large-scale professional application and teams building production systems. Next session, we go deeper into interfaces, types, objects, and functions in TypeScript and learn how TypeScript is used in React and backend APIs. Great job today. And journey from beginner to professional is happening one step at a time. Thank you and welcome officially to the TypeScript world.